So this is day 2. Day 1, we talked specifically about perpendicular bisectors. Here, we're talking about angle bisectors. So we still have the word bisector, but some specific things have to be true or hold true in order to be what we want. So first of all, an angle bisector. We've seen the word bisect a lot throughout the year, saw it a lot yesterday, but this one's an angle bisector. So, for instance here, I would say segment or ray, AD, is the angle bisector of angle BAC. Now, a couple of things that I will mention here. First of all, we know it's the angle bisector because we see these two angles being congruent. Okay, it bisects, it splits it in half. When I name this big angle here, I still see some issues with like naming angles and knowing what to name. We can't call this angle A because this is angle A, this is angle A, and then the big one's angle A. We've got 3 angle A's here. That's why we can't say angle A. So we have to either call it BAC or CAB. Either one of those is fine, but you have to use 3 letters when you're naming an angle like that. So we know exactly which angle A that we're talking about. Biggest thing is A must be in the middle, right? A's got to be in the middle of that. And then notice I use a ray here. We haven't seen rays for a while. This is ray AD because we have an endpoint and it goes on. I could also call it segment AD, which means it would have to stop at D and just that right there. So that's why I would rather use ray because it does go on forever. Okay, so that's what we call an angle bisector. Well, when we talk about the angle bisector theorem, we're going to take it a little bit further, and we're going to say if a point lies on the bisector of an angle, like for instance this is point D, and it lies on the bisector, then it is equidistant from the 2 sides of the angle. So we know that this and this would be congruent, okay? But the thing we have to ensure is that this is a 90 and this is a 90, okay? We want both of those to be 90-degree angles. Otherwise, if I were to draw a picture like this, and let's say D is here, those 2 segments would not be congruent, okay? This one here is maybe 90, but this one is not. So those 2 segments would not be congruent. So the fact that we put a 90-degree in here ensures that they form the same angle with each of those sides, and then these 2 would be congruent to one another. Okay? We're going to use that a lot today. And then we talk about the converse. Well, the converse is giving us information the opposite way. If I give you an angle, and I have a point on the interior of that angle that is equidistant from the 2 sides. And once again, we want both of these to be 90. And I'm telling you that these 2 are congruent. Okay, so if these 2 segments form a 90 and these 2 segments are congruent, then what we can conclude is P is on the angle bisector. So I could draw that bisector through there, and I know that these 2 angles would then be congruent. So it kind of depends on which way we're given the information, right? Which direction we go with it to get there. Okay, so using that piece of information right there, if we look at the next picture with the soccer goalie that's sitting in there, okay? The soccer goalie is sitting in between the goal, where he should be, right? But right now, he's not centered. He's a little bit to the left of center. Is he in a good position to stop the ball? if you were the goalie, where would you want to position yourself to give you the best chance of stopping the goal? Right in the middle, right? And right now, he's not really straddling this line right here, okay? He's a little bit to the left of it. So would he be in a good position where he's at right now? Probably not, right? If I was the guy kicking the ball right here, then where would I kick it? To the left, right? Because there's more room there. And he's going to have a less chance to get there, okay? He's going to be easier to get to this side. So he wants to go right into the middle, and right in the middle is on the angle bisector. So basically he would put one leg on either side of that angle bisector, be right down the middle. And so we would say something here like, if the goalie stands on the angle bisector, or splits the angle bisector, however you want to say it, then he is equidistant from both sides. Gives him a better chance of making the stop. So that means goalie's got to be pretty good at geometry, right? It's all about geometry. If you want to know when we ever use stuff like this, it's all about geometry. Use it all the time. Okay. What about this one here? Is there enough information to conclude that QS is the angle bisector of the big angle? We know these two are congruent, okay, which is good. We don't know if these two are congruent. If I had these two marked, then obviously they would be the angle bisector, right? But when we say that it's the angle bisector and that it lies there, we got to know two things here, okay? The two things that we have to know are these two have to be congruent, and what else? We need 90 degrees. We have no idea what this angle and this angle here are, okay? And it's because we don't know what that angle is, then we would say no. We need angle P and angle R to equal 90 degrees. So it's just missing that right angle. Okay. Could QS be the angle bisector? Absolutely, right? And we just don't have quite enough information yet to determine that. Okay, I'm going to kind of tell you the same thing I told you yesterday. When we do a lot of these, the math is not the hard part, but understanding why and how we can do each one of these pieces is the most important thing. Okay, and that's why yesterday you had like a text box on a lot of your big idea problems, and you just had to give me a little bit of a reasoning as to why you know that would be true. Okay, and today's going to be very similar to that. So I'm going to kind of show you what I'm looking for. It doesn't have to be a big, lengthy explanation when you type something in that box, but it has to be something as to know, why do I know enough information to get where I need to be. So, looking at this one here, we know these two segments are both 7, so we know these two pieces are congruent. We know these two pieces are 90 degrees. Therefore, we know FJ, ray FJ, is the angle bisector of angle GFH. So I know these two angles are going to be congruent. Okay? So that would be kind of my reasoning. Or you could even say something like, we have two 90-degree angles, and GF and HJ are congruent. Okay? There's a couple of different ways that you could say that information, but we do have enough information to prove that FJ is the angle bisector. So, if this is 42 down here, what's the piece up here got to be? 42, okay? There's not a whole lot of math involved there, but you do have to understand why. Okay, if I didn't have all that information there, then I wouldn't be able to get to the point where I can prove that. Okay, so that's a really important piece to prove. Okay, this one here, they're giving us a little bit different information. what we are given here is these two are congruent. So what's that tell me about QS? If those two angles are congruent. It's the angle bisector, right? So we're going to say QS is the angle bisector. And because S falls on that line, on that ray, and we know these are both 90-degree angles once again, then I know that this piece is congruent to this piece. So I'm going to say that PS is equal to RS. And we know the expression for PS is 5x. RS is 6x minus 5. Hey, if we were going to solve this one, what would be the next step? What would be my first step trying to get x by itself? You could minus 6x, okay? Now that gives me a negative x. Is that okay? Yeah, that's okay, right? We can have negative as we go throughout. Last hour we talked about I could add 5 and then bring the 5x over here. There's more than one way you can go about solving this. If you like to keep things positive, there's nothing wrong with that, okay? But it's okay to go negative too. If I were to subtract 6x, you just got to be a little bit more careful with your signs. And then I would get x equals 5. Okay, here's where you also got to pay attention. What are they asking us to find? All we did so far is finding x. We want to know what is rs. So we got to take x, we got to plug it back in, and we got to find the length of rs. We know that rs is 6x minus 5. So rs would be 25. Okay, and I'm going to show you this. I like to do this to kind of check myself, because if I take 5 and plug it in on the other piece, 5 times 5 is 25, and what do you know? PS and RS are the same thing. And so that kind of tells me I did everything right? If I can get those two to be the same answer, then I don't have too much doubt that my answer works and that x equals 5 was the right answer. Okay, we've also talked about how when we're given information, sometimes it's marked on the picture, sometimes it's just written out as a statement. This one is not marked on the picture. They got the picture over here, we got the information in a statement, but what I would always say is mark that information on the picture. It's kind of like what we did last chapter when we did side, angle, side. If we had everything marked, it was really easy to go side, angle, side, angle, whatever pieces we had. If you don't mark it on the picture, makes it a little bit more difficult, I think. AD is 3.2. CD is 3.2. So I know those two pieces are congruent. Immediately know those two pieces are congruent. I also know these are 90s. So what can I say about BD?
What's the angle bisector?
BD is the angle bisector. So then I can immediately say these two angles are the same. I know the measure of DBC. Follow the path of the letters. DBC is this piece right here, 39 degrees. If this angle here is 39, what's the one angle on the other side going to be? 39, right? All those markings help us get to that point. But we go back to the beginning, and it says find the measure of ABC. Follow the path of the letters. Here's A. We're going to go A, B, C. Okay, we're talking about this big old angle right here. This is 39, this is 39. These two together make the big angle. So what I am going to have to do here is either take 39 plus 39 or 39 times 2. Which would be 78. Okay, like I said, the math shouldn't be real difficult today. A little bit of solving equations, but just being able to use the information that we're given. Okay, BD bisects angle ABC. So I know those two pieces are congruent because it bisects it. I know these two are both 90-degree angles. So then what I know is that AD and CD are equal. AD is 3Z plus 7. CD is 2Z plus 11. So I'm just going to input that information in for AD and CD. I know that they're equal, and then we're just going to solve for Z. Subtract 2Z from both sides. That would give me Z. Subtract 7 from the other side. I get Z equals 4. Okay? But it's not asking me what Z is. It's asking me what the length of CD is. Well, CD is 2Z plus 11. So I'm going to come over here. And we're going to take 4, and we're going to plug it in for Z. 2 times 4 plus 11 would be 19. Okay. If I wanted to verify that both sides are 19, then I could plug it in here as well. 3 times 4 is 12. 12 plus 7 means AD would also be 19. So there's good news, right? Both of them equal 19, so we must have done something right. You don't necessarily have to find both, but I think that's a good way to kind of check your answer if you aren't really sure if you did the work right. All right, these last two problems take a little bit of time, okay? This one has a picture just so we can kind of visualize what's going on. This one down here does not, okay? So I'm going to show you how you do it with the picture versus without. There's still some work to be done no matter which way you do it. All right, so the first one. We have 2 points, -2, 3, and 4, 1. We're going to plot those 2 points. Connect them together and make a segment. There's PQ. We want to write a new equation that represents the perpendicular bisector of the segment to this segment right here. Okay? So we need to know 2 things. Perpendicular and bisector. Okay? So we got to do one thing at a time here. We can't do them both at the same time. Let's focus on perpendicular first. What is the slope of PQ? Well, there's a lot of different ways I can do that. But when I'm given a picture, I can just do rise over run. To go from P to Q, I'm going to go down 2, and then I'm going to go over 1, 2, 3, 4, 5, 6. Down 2, right 6. I'm going to reduce that to be -1 over 3. That's the slope of the original line. We want to find the slope of the perpendicular line. We've talked about this a lot. We had a problem on our test in chapter 5 about are these two perpendicular to one another? How do I know, or how do I find 2 slopes that are perpendicular? We've got to do 2 things to it. Flip the switch, okay? We're going to flip it over, and we're going to switch the sign. So if my original slope is -1 over 3, and I flip the switch on it, it becomes positive, and then I would put 3 over 1, but we don't really need to put it over 1, so it's just going to become +3. That's my new slope. Okay, second thing is the word bisect. If something is bisected, then what's that mean? Half. Okay, so we have to find the halfway point of PQ. PQ is a segment, so it stops on both ends. But I got to find the halfway point. Don't always just look at it, and sometimes that's where the picture can be a good thing versus a bad thing. Sometimes we think we can just look at it and boom, what it is. What happens if it's a fraction or a decimal, right? So in some cases, looking at the picture might be okay, but to ensure that we find the point right in the middle, we have a formula we haven't used for a while. We're going to do the good old midpoint formula. So we have to find the point that's right in the middle of those 2 points. The midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So we got to make sure we add the two x's together. Negative 2 plus 4 is 2. 2 divided by 2 is 1. 3 plus 1 is 4. 4 divided by 2 is 2. Okay, so 1, 2 is my point. All right, the last thing, and this should be the point, just to make sure it makes sense, if I did my math right. This point should look like it's the halfway point of that segment, which it does, okay? Now, the last thing I got to do here is I got to put this into an equation, right? An equation that represents the perpendicular bisector. So we're going to write an equation that has to have a slope of 3, and it goes through the point 1, 2, because the line's going to go right through the middle of that segment. So I have an M, I have an X, and I have a Y. There's a couple of different ways that you could do this, but the one I think we've used the most is slope-intercept form, y equals mx plus b. That would be the way that we usually choose to write our equation. In this equation, we know 3 things. We know x, we know y, and we know m. We do not know b. B is our missing value. So we're going to plug in the 3 things that we know. My y value is 2, m is 3, x is 1. 3 times 1 is still 3, and 2 minus 3 is negative 1. Okay, so my final answer y equals 3x minus 1. This is our slope, and b is negative 1. Okay, if I were to graph this, just to kind of show you what's going on here. There's my line, right? This line should do 2 things. Just to kind of verify that it looks good, that it makes sense. First of all, it should split this in half. It should bisect it. Well, we already talked about the midpoint does that. So we know that it bisects it. The other thing that it should look like is it should look like it forms a right angle. If it doesn't look like it's forming a right angle, then probably something's not right, okay? But this is the equation of this line right here, and that's what we're trying to find. This line is the perpendicular bisector of that. Now, we don't necessarily have to do the picture every time, so that's why on this one we didn't give you a piece of graph paper. We can do it without graphing it. Graphing it almost kind of takes a little bit more time, but it does give me at least a little bit of a visual of what's going on so we can see if it looks right and makes sense. Okay, this is basically the exact same problem with just different numbers and no graph, okay? We have 2 points. The one bad thing about not having a graph is I got to find the slope another way. I can't do rise over run because I don't have a graph to get the slope from. So then if we don't have a graph, we're going to do our slope formula. y2 minus y1 over x2 minus x1. All kinds of good news, right? We get to use all these formulas that we've talked about all year long. slope and distance and midpoint and all these things, they just keep popping up. You guys love seeing them, right? Well, good thing is that that'll help us get ready for the final, which is coming up in about 3 weeks, right? You get to look forward to that. Okay, be careful with what's what here. y2 minus y1. -1 minus -5. Really be careful of your signs here. 3 minus -1. -1 minus -5 is really -1 plus 5, which is 4. 3 minus -1 is really 3 plus 1, which is also 4, which gives me a slope of 1. Okay, the perpendicular slope. What would be perpendicular to a slope of 1? -1. If I flip 1, doesn't change anything, right? 1 is 1. Doesn't change anything. But we do have to do the opposite. So my perpendicular slope would be -1. So that's the first thing. Perpendicular bisector. Bisector means we're looking for the halfway point. So now we're going to do midpoint of, I'm going to bring these two ordered pairs down here. -1 plus 3. Make sure you add your x's together. Add your y's together. -1 plus 3 is 2. 2 divided by 2 is 1. -5 plus -1 is -6. Divided by 2 is -3. So 1 -3 is my midpoint. Okay, finish it up. We know the m, we know x, and we know y. Once again, we don't know b. B is what our equation is missing, okay? We're going to plug everything in that we know. My y value is -3. My m is -1. My x is 1 plus b. And then we're going to add 1 to both sides. And there's our equation. This is our slope, which we did up here. This is our b value, which is right here. Sophia, question? Okay, that's all we got.